We're going to look real quick at number 16 in section 4.5. It just tells us to evaluate the limit. Of course, we're anticipating in this section that L'Hopital's rule might appear. Remember L'Hopital's rule, we're looking for limits of the form 0 over 0 or infinity over infinity. Those indeterminate forms, right, generally speaking, are going to be using L'Hopital's rule. Now, a couple things. We've got an inverse sine function here. That's what that is, sine inverse or arc sine. Recall the arc sine of 0 is 0, and that's true because sine of 0 is 0 with 0 between negative pi over 2 and pi over 2, which is the range of the arc sine function. The derivative of the arc sine function. So this is not sine of x. This is not 1 over sine of x, which is cosecant x. This is the arc sine function. If you remember, that's the derivative of that. We derived that when we did that section on the derivatives of the inverse trig functions. Furthermore, if you've got sine inverse of u, where u is some function of x, then it's chain rule, right? So it's the derivative of the outer function, which would be 1 over 1 minus u squared, times the derivative of u, which I just wrote as u prime. And so multiplying by u prime, and just put it in the numerator. So this is the derivative in that case. So that'll be helpful in this problem. Here's the problem. Take the limit as x approaches 0. 5 inverse sine of 9x divided by 3x. Well, if I plug in 0, obviously the denominator is approaching 0. And up top, 9 times 0 is 0. Inverse sine of 0, as we said, was 0. So we're getting 0 over 0. So I can use L'Hopital's rule. And what's the derivative? Well, the derivative of the bottom is easy. It's just 3. The top is 5, right? Constant multiple times what? What's the derivative of sine inverse of 9x? Well, that's the chain rule here, where u is 9x, right? What's the derivative of 9x? It's 9. That's the derivative of the inner function. Right, and then the derivative of the outer function would be 1 over 1 minus u squared, where u is 9x, right? So 1 over the square root of 1 minus 9x quantity squared. That's 9 squared, which is 81 times x squared, right? So there's the derivative, okay, of the numerator over the denominator. Now, what happens is x goes to 0. There's only one x here. And as x goes to 0, notice this fraction here, the 1 minus what? 0, right? 81 times 0 squared is just 0. 1 minus, I get 1. Square root of 1 is 1. So this whole fraction becomes 9. 5 times 9 is 45, divided by 3 is 15. And that is the limit of this expression here. So that's a quick one. Do have to remember some of your derivatives of some of these transcendental functions that we don't use quite as often, but are important nonetheless. Okay, hope this helps you.